I need to know. Uh, Twitch. Oh, okay. I don't think it is. Slim, thank you so much for the raid. I was lurking on you. I hope your stream was good. Um, for those new here, I'm Don. I do math streams, and on Saturdays, like today, I do reading group on general relativity. So we're about to go and solve some problems out of this book here. Hey Finlux, hey Rex, streaking like a comet in 4D space time. Hell yeah! Stream was like a refreshing lemonade on a hot summer day. Nice, the best kind of stream. Um, am I forgetting anything? I think we're good. I'm gonna hop in Discord. We're not gonna have FizzBuzz today. I really think I'm forgetting something, but I don't think I am. I think I'm forgetting something, but I also don't think I am. So that works. Then I assume Felix will hop in whenever he's ready. Um, oh, there you are. Felix will hop in whenever he's ready.
Hey.
Hello, hello. How's it going?
You know, the usual.
Yep, I'm ready for more confusion.
No, but I'm here anyway.
Dover wasn't important? Yeah, okay. Okay, so I think last time we got the number 4. Next one I have marked is number 8. Oh, good. This one has an S by it, so that's allegedly a straightforward, simple question.
Nice.
I'll give you a minute to get the Excalibur open.
Oh, good. It's hyperbolic angles.
Yeah. I should probably grab that figure. Why didn't I think about that in advance? Um, Kubrick, do I know about the Pahal Gam attack? That sounds like a chess thing, but no matter what it is, I haven't heard of it. Um, oh, where is this file? Is it that one? Oh wait, I already took a screenshot of it. Oh my gosh, I don't need to do all this. Oh, it's a storm that happened in India. No, I did not hear. Oh, oh, I think I know what you're talking about now. I did hear about that. Hey, JGOXT, welcome in. University Physics by Young Friedman. No, I haven't. I've heard of it, but are you able to find the link, Femlux?
Yeah, let's find a link here. I gotta push this little open chat button and all right, I think I'm here.
Yeah, Kubrick on Saturdays we do this physics reading group. Okay. So this is that same figure where B prime is supposed to be. Actually, they're not asking about B prime, but B prime is a little bit offset for some reason. Um, and so another good thing about this is that this description tells us what hyperbolic angle even is. Ratio along a distance along these hyperbolas the distance from the origin. So it's the arc length of the hyperbola divided by the hypotenuse of the triangle. It's a hyperbolic angle. But then how do we actually get... We need the angle between AC and AB.
Can we calculate gamma based on the triangle? I think we can. I want to say we can, I just don't know how to do it.
Sorry, what did you say that we think we can?
Gamma.
Using gamma?
The only reason I'm thinking of gamma is because I came up with that gamma equals hyperbolic cosine of the angle.
Oh.
Does that help? Then we'd have to do an inverse hyperbolic cosine.
I mean, what velocity do we have, though, to find gamma?
Well, it's got to be something to do with the slope of AC, doesn't it? Actually, AC is... A and C are space-like separated, aren't they? I guess that doesn't matter.
Hmm.
So does this
What
mean
is...
there's like an
Oh, sorry. Go on.
so the hyperbola we're thinking of, is it going through point C, right? And then it would come down and intersect AB somewhere. So we're kind of thinking of A as the origin, right? That's how I'm thinking of it.
Yes. It'd be nice if we can just kind of divide one space-time distance by the other and do like an arc cosh.
Can we just say, I mean, I know this is probably not the best way to do it, but can't we just say like y squared minus x squared equals 1 or something? And or y squared minus x squared equals something. Five and 3. Let's see, 25 and 4 squared, right? X squared minus y squared is 16. So we're going over 5 and up 3. I'm writing on paper. I shouldn't be writing on paper.
If you want to like do it on paper to play around with it, but
yeah, but I got to get better at using this Excalibur stuff. I've been on myself about this. You know, I'm just kind of like an old dog, and I'm trying to learn a new trick here. I'm thinking of something like this, right? Some hyperbola like that. Whoops. But you know, something like that. If I erase that, is it going to erase the whole picture? Please don't erase the whole picture. Damn it.
there's always
What do I
an
hit? Control Z?
undo. Yeah, Control Z.
Control Z. Maybe I just screwed up our picture.
No, we can fix this.
I could hit Control
there.
Z again, couldn't I?
Oh, no, that I just like selected and deleted it, but yeah, that would have worked too. Hmm.
Yeah, so what I'm thinking is that, so if we look at this picture, you know, I'm thinking of this as A, and here's C, and then B would be right there, right? There's our triangle, ABC there.
Oh yeah.
So I want to find this point if I can over here, maybe here somewhere,
Oh,
where this hyperbola comes like that. I don't know if that's a good way to do it. Maybe there's a better way to do it.
yeah. I guess the thing that's what I would want to do too. I think if we try to get the arc length of the hyperbola, then we're going to run into a tricky integral.
Yeah, I don't want to do any integrals
Um,
if I can help it. I'm still, coming up against the fact that I don't know what a hyperbolic angle is. I mean, what does it even measure? Is it a radian? Is it in radian measure like regular angles? Is it a ratio
uh,
between two sides of a triangle? Can I draw a triangle? And
yeah. I mean,
it's funny, I don't remember ever learning about a hyperbolic angle. And like you, when I went to Wikipedia and looked it up, it was talking about like an area in terms of an area. And I
yeah,
thought, well,
because
that sounds hard.
it's really analogous to a circle, but it's not like periodic. Like it goes from minus infinity to plus infinity. It's not 0 to 2 pi.
Yeah.
But there's a relationship between like radians in the area of the circle, and I think the similar thing happens there.
Hmm.
Um, okay, this one has an S on it. I thought this would be an easier
No,
one,
no, no.
but
It will. No, no. We'll get it. We'll get it.
and
So,
yeah, it should be
so
easy. We
let
just
me
need to
just
know
say.
how these work, I guess.
I mean, I can definitely say this.
Yes.
Oops, if I could right there. I mean, that's got to be true. So, so even if we found gamma, right? Even if we found out what this cosh theta is, we'd still have to unwind this this yucky, you know, all these exponentials.
Hmm.
Did you agree with this idea I had, which was this? I wrote it down in the book somewhere. Doesn't mean it's right. I just thought it was right.
Uh, that was the thing. That's how they got to like the hyperbolic rotation being a boost, I think.
Yeah, the section on Lorentz boosts.
But the thing is, like, we don't have any velocities here. That's what I don't like. And so I don't know if that's like generally true, but I think you're able to take gamma equal to cosh theta
I want to say
to
the
do that.
velocity's got something to do with the slope of
Oh, you're right.
AC.
Yeah, it would. Okay, that's maybe that is the thing to think about then. So if the slope, oh wait, we shouldn't. I shouldn't just count the tick marks here to get the rise overrun. We should get the hyperbolic distances. Which I'll just we've done this example individually, so I'll just look at the answer for what the sides of the triangle are. I can find it. Um, okay. AB is 5, like normal. BC is 3. That doesn't look like a 5. That looks like a 5. 3. And AC is 4. Who even likes a triangle inequality anyway? I wonder if you could define a different triangle inequality for this.
I was
Anyway,
just thinking about the triangle inequality the other day. It came up in the chapter 1 of that complex analysis book.
oh cool. Hi Central, bye Central. You're streaming right now, aren't you? I still haven't even started on that complex analysis. I need to set a date for that too, since the poll was over. Oh, you know what? I realized that I can't see who actually voted in the poll. If you were one of the people who voted, can I ask which ones you put? Sorry, I know this
I
is
did not.
random. You didn't?
No,
Okay,
I actually didn't vote. No, I didn't. I
that's
didn't know
fine.
if I should or not.
No, I mean, I put, I'm probably just gonna choose a Tuesday or a Thursday at 3 Pacific then. But I just wanted to check like which ones like worked with you if you had. But
It
if not, it's
doesn't
fine.
matter to me. It doesn't matter to me.
Okay.
Um, Somebody in another stream was mentioning that 3 Pacific is like midnight over in Europe.
Oh yeah, and like Central or Eastern Europe, it's
Yeah, so I
midnight.
don't know if that makes a difference. I mean, I think you should just do it when it's best for you, honestly. I mean, I don't know.
I
Probably not
mean,
worth worrying about.
I guess so. I just want to. If someone's interested in it, I'd like to be able to include them if I can.
Yeah, no, I get that.
Um,
Yeah.
I don't know. And Naman, I'm reading the YouTube chat. I'm just letting you two seem to just be going back and forth with each other, and that's completely fine.
Would it be better for you to start it at three your time or 1 your time?
It'd be a little more convenient if I started at 1 my time, but
Yeah,
I
that's what I was thinking. Because otherwise, if you're gonna keep your hours, then you're 2 hours into streaming, and then all of a sudden you got to do the read. It might be like harder to pick up a reading group right after you've already been streaming 2 hours. I don't know.
yeah, I might just start later on that day or something if I do that time. But I put
Oh
the three
yeah,
o'clock there for you since you would be working then, I think. And you said that you were interested, so I can always try and figure something out.
yeah. I mean, the tutoring center I work in stays open till 4 my time, which is 1 your time.
Yeah, so
So,
that's
and
a
then
little like close.
on certain days I could, and sometimes I stay later if there's still students in there.
Hmm.
I mean, I just hang out and keep working with them for some reason. So I might be late some days, but it's not a huge deal.
Okay. Um, yeah, I mean it. If you're okay with that, then I could choose like my normal time. Um,
Anyway,
yeah,
you could think about it and we can discuss it. Because Slim was talking about it on his channel too. I think he wants to definitely be involved.
yeah, and I know he's usually around like earlier in the day too, so I'll send him a message after this. But I'm hoping to set an actual date today or tomorrow for the first time to meet.
Nice.
So yeah.
So this
Um.
hyperbolic angle.
So yeah, so the rise over run, this would be 3/5. If we want to think about like the velocity, I guess it'd be like three fifths the speed of light. That probably doesn't matter.
Maybe it's 5/3 the speed of light. Is
You're
that
right.
AC? Is
Oh, that.
Yeah, because that
No.
AC is sort
Oh
of
wait, oh yeah,
flatter
it's
than.
flipped. X is horizontal.
Yeah.
Do we care? But no, it can't be 5/3. That's faster than the speed of light.
Yeah, it would have to be a tachyon.
Yeah. um. Wait. What? So. Oh wait, this thing is faster than the speed of light. Because
Yeah.
that's the 45-degree line, and it should be to the. Oh. Well, that makes this even worse. I don't think our formula applies to this.
It doesn't. Well, I think it should still apply, shouldn't it?
Don't we get it to square root of a negative?
No.
Because it's 1 minus 5 squared over 3 squared. Huh. Third do physics study session more inclined to. I sometimes do mechanics studying just randomly on stream. And hey, MMD. Um, if we just didn't want to think too hard, like, what about like saying cosh theta is 5/4? What answer would that give us?
Okay. Yeah, maybe you can just do that. See, I just don't know if that's legit, but maybe we can just do that, right? Is that how that works?
I, hell if I know. I see what number I get out from Wolfram. Oh, it's ln of 2 apparently.
Hmm.
That is kind of clean.
Yeah, I like it. What about no. I was thinking of something else I saw in the book, but it's actually at the start of the next chapter, so I don't think we should really be worried about that.
Okay.
Is that my computer making a Discord noise? Sorry.
No, I don't hear it.
Okay.
If these distances are already hyperbolic, I wonder if we've taken care of kind of like whatever's on the right. Um, and ln2 is less than. Well, wait. What would I expect 45 degrees to be?
Yeah, LN2 is less than 1.
Yeah, I don't know if 1 is the significant number to think about. I assume there's some like critical angle right at 45 degrees. What is our cosh of 1? Actually,
Isn't
wait, that would
the
be our cosh. I don't
isn't theta supposed to parameterize the arc length of the hyperbola?
know.
What's the
Yeah.
Yeah, because if you got a unit circle, it parameterizes the arc length, doesn't it? Maybe it only works if you got a unit hyperbola.
Yeah, I mean, all this is defined with a unit hyperbola.
Wouldn't that make this even worse? Because I'm thinking that if it was an arc length, and I don't know if it is, but if it was an arc length, that would have to be more than log 2, wouldn't it? But maybe not because we're in non-Euclidean space here again. But I want to say if this was an arc length here, this red thing, it doesn't seem like that's ln2.
Hmm.
Um, what is
The distance between 2 points. ds squared for this case is just minus c dt squared plus dx squared. I don't know, in a way, I feel like by getting that 3, 4, and 5, we've already accounted for the hyperbolic arc length somehow. I just don't have a hard time, or I have a hard time saying why. Hey, Bib. Nice to see you too.
I'm just trying to look at I got the Wikipedia page here for hyperbolic angle. I'm just looking at it.
You bring it up too. Okay, so the hyper but the sector is still really annoying to find with calculus or hyperbola. So I think I tried doing that too. Or is it? Yeah, it is. I mean, we could just do it numerically though with Wolfram.
Yeah.
Um, so we would hyperbolic sector is an area half of the angle. So if we could find the area, multiply it by 2, that should be our angle. But what area? I guess A is the origin and C is the point on the hyperbola.
Yeah.
Um,
Well, I was thinking of A as the origin. Do you think that's what they mean? I would assume we're supposed to treat A as the origin.
yeah.
Yeah.
Just if that's 5 and that's 3, does C check out as being on the hyperbola? Uh, x squared minus y squared equals 1. I don't think that does. 25 minus 9 equals 1? Unless I'm thinking about this wrong.
That's 16. So maybe we have to multiply everything by. Oh, maybe we have to multiply it by 4 because look, AC you calculated has length 4. So that means our hyperbola is 4 units from the origin instead of 1, right? So maybe we need like 4 ln2. I don't know.
Hey, Colton. Um, it would have to be only a small number of triangles would actually fit on the hyperbola in the way we're trying to do this. Sure, if you want to get the angle for any arbitrary triangle, there must be some type of warping thing that you have to do, like you're saying. Or there,
What does it say in this under the figure here? It says the hyperbolic angle theta shown is the ratio of the space-time distance along the hyperbola from the x-axis to the space-time distance of the hyperbola from the origin. Well, we don't know either of those two things anyway, do we?
No.
Because I don't know where the vertex is, and I don't know what the arc length is. Yeah, I was so confused. I spent, a couple hours one morning trying to look up hyperbolic angles, and I really didn't feel like I understood what was going on. So I just figured, well, let's keep going.
Okay, I'm seeing on the Wikipedia page for hyperbolic functions, it can be shown the area under the curve of hyperbolic cosine is always equal to the arc length corresponding. Oh, that's the arc length. No, that's the arc length of Koch, not of the hyperbola. Never mind. I think this isn't telling me what Koch and sinh actually are. Hey, Krim. Oh, Fizzbuzz to the rescue. It is as simple as doing arc Koch 5/4 or any of the. Oh, yeah, we could check that with arc sinh being equal. Arc sinh 3/4. Do we get ln2? We do. That makes me feel better. Arc then 3/5. Okay, that's also ln2. Okay. It probably is just ln2 then. I wish there was a. I want someone to tell me exactly how hyperbolic geometry works though.
Oh, it
Feel
works. It
confident.
works if we plug it back into the definition for hyperbolic cosine in terms of exponentials, right? Like 1/2 e to the ln2 plus e to the negative ln2. I didn't think of checking that, but it's just 1/2 of 2 plus 1/2, and that's 5/4. So
Hmm.
I guess it checks out with that version of the formula. So, okay. So I want to understand then that I can look at a look at a triangle on a space-time diagram like this, and just put theta down there in the bottom left-hand corner where I'm happy to put the theta, and then use the quotient, sine, and everything, and just do it like I would do sine and cosine, right? This is what I've been trying to worry about. It's like, can I do this with a triangle? I guess the answer
Same.
is yeah, you can do it. Yeah.
Hey, Phobos, it sure is. We've been struggling with what it means for a long time.
Yes, hyperbolic angles came back to bite us once again.
Krim, I'm gonna refund your points for now. If you want to do a reskeep out, I have to do it after the reading group. Sorry, I just like to focus on this. Um, in sec lane, calculus gets really difficult here. Okay, are good with checking the or like are okay if I check the answer on this?
Yeah, sure.
Okay.
Yeah,
Number
but look
eight.
at that triangle, Phobos. The 4 is in the wrong place.
Yeah.
The 4 and 5 are in the wrong place. We're all twisted around.
Um,
We
avert my
left Euclid
eyes.
far behind.
Yeah. Hyperbolic. They use uh hyperbolic tangent. Uh,
0.69, there it is. Log
yeah.
2.
Do you just
Magic
like
number.
happen to know that?
Yeah, because it's the magic number.
Love it. Okay. I guess it is that simple. Um, Texas too boring. You have to do it to begin in computer science. That's fair, Sackling. All right. Where's my problems? Number 9 is the next one I have. Oh, it's a twin paradox one.
Okay. I read a little bit about that recently.
Okay. Consider twins, Joe and Ed. Joe goes off in a straight line, traveling speed of 24/25c for 7 years as measured on his clock, then reverses and returns at half the speed. Ed remains at home. Make a space-time diagram showing the motion of Joe and Ed from Ed's point of view. When they return, what is the difference in ages between Joe and Ed? I feel more similar to Ed here, just staying at home. So we have an X and we have a CT axis. Returns at half speed. Okay, so
That could be like a light ray.
they famished. Yeah, nearly, just barely, like just a slightly higher angle.
Yeah, let's say this is 45. So at a speed of 24/25 c, so just above it, you're saying, right?
Yeah, so like if this is, or I guess I'll draw more to the left. If that's Ed staying at home,
Okay.
I guess Joe, if that's 45, Joey going in a straight line, just a straight line, something like that.
Okay.
And then he, at half the speed, I guess 45 is also like that. He'd be going at a different slope like that ish. Guesstimating what half of that angle would be. It's been good, famished. How about you? Maybe I should do different colors.
I don't know. Make a space-time diagram showing the motion of Joe and Ed from Ed's point of view. Okay, Ed was the guy who stayed home. Okay, good.
Yeah.
Thank goodness. Okay, so Ed is just going vertically. Ed's world line is vertical. And then
Mhm.
Joe has these two angled lines. Joe goes off in a straight line for 7 years as measured on his clock.
Babysitting. Oh, nice. See, I guess we should be able to measure the. We probably need the distance. We know the speed and we know the time.
Okay, I like that idea.
Um, and this is all in Joe's frame, the 7 years. So I don't think we need to be any fancier than just. Well, do we want years? I think we just do the 7 years divided by the 24 or 25C, but I'm just debating the units.
If he comes back at half the speed, then doesn't that mean
We're gonna have to figure out how long. I guess it'll be 14 years that he's going in that second leg of the journey.
yeah.
This is like the proper time
My
we have.
question is, should the second um side of that triangle, should it be even steeper? Instead of like half as steep, should it be like twice as steep? I
Uh
think maybe it should be.
oh, you're right. It's these axes being flipped.
Yeah, physicists have to do everything their own way.
Yeah. So it's more like that. Then I'll drag Ed's world line up to match. So if I do 7 years divided by 24 divided by 25 times speed of light, what does Wolfram Alpha tell me? Seconds per square, what? Speed of light in meters per year. Isn't that just one? Or no, it's not. Wait, am I doing this right? Do I need to flip it the other way? No? Yeah, I'm doing this wrong.
For this question, do we want to? Because that does say 24 over 25C, right?
Yeah, it's a little bit blurry,
Got
but
a little bit. Okay. Because I was wondering if this is one of the ones where we got to treat C as one, but probably not for this question, right?
I think it's for like next chapter they're doing that.
Where that comes in. Okay.
Wait, okay. If I travel for 10 seconds at or like 12 meters per second, how do I oh, I multiply. That's okay.
No, we
There
multiply.
we go. Makes more sense. Well, that's a lot of meters.
Yeah. Can't we just leave it as 7 times 24 over 25
That's
and
probably
keep the
better.
C with it? Let's just do that.
uh 7 times 24 is 168.
Oh yeah. Number of hours in a week.
Oh, yeah.
So we agree that Joe is going to take 21 years total, right?
Yeah.
The question is like how much time went by for Ed?
Hey, Gothamman. Yes. Thank you, thank you. Um, and so Ed should measure a longer time than 21 years.
Yeah. So can we break this picture up into like two triangles, maybe? Like put a line across here. Because that's the distance you just found, isn't it?
I think I thought I found that distance. Or no, no, you're right. I found that distance. You're right.
Yeah.
And so if we know that ds squared is in, there's probably a shorter way of doing it than this, but if ds squared is invariant, we I am Kurt, thank you for the follow and welcome in. Hey, if ds squared is invariant, we could calculate it in Joe's frame and then figure out what dt must be in Ed's frame. But there must be like a time dilation thing that we can do that's quicker.
I really like doing it with the pictures, if we can.
Okay.
But, it's great if we can do it more than one way too. That's great.
Yeah.
I've been
What would
reading
be the
that other
picture
book
way?
that I told you about, and it's always dealing with
Mm.
these diagrams.
Mm-hmm.
The thing is that the author, I've been reading along, and the author's very gentle, and he sort of explains it all. He really dumbs it down, and he kind of explains it easily. But I haven't really been trying to solve any problems myself. And when I'm stuck with a problem like this, where I have to actually construct a space-time diagram, I still feel confused. Like, for example, the CT axis. So where's time? Isn't that confusing? So where's time? Is it because we did CT so that we could convert all the units to be the same, didn't we? Like everything's measuring meters now, isn't it?
Mm-hmm.
Everything's a distance. So
So like that distance is 7 years, and the upper distance is 14.
but are they?
And
Because
then we
aren't
just
they?
found
How
that
can we
side.
say? How can we say that's 7 years though? Because
Well,
I mean,
7 years times the speed of light.
okay.
I guess it's the distance light moves in 7 years. It's not 7 years itself.
Okay. So tell me if this is correct. Let me write something down here.
Okay.
Let me say, let me label some points here. We'll call this A, we'll call this B, and we'll call this C, because that's nice. Now, down here, I'm going to try and draw this. Here's A and B. I want to know if this is accurate. And this is 90 degrees on the,
Mm-hmm.
so that's that point we were just talking about. We'll call that D maybe. So here's D. So what would D represent? D would represent, I don't know what it is. Anyway, so you worked out this is 168 over 25C, and we said that was this side, wasn't it? So this I'm going to say is 168 over 25. And is it legitimate to say that this side over here is 7 then? Is this correct? Can I say
Oh,
that?
not in Ed's frame. In Joe's frame, it's seven
Oh,
years.
you're right. That's not 7. Thank you. So, but
We need
if
to
they told us
get
it was in
gamma.
Ed's frame, I could have probably done that.
Yeah, I mean, we just take 7 years, multiply it by gamma, I think, and we'd be okay.
Can I
Um,
put the 7 here, or is that no good?
no, that should be close to 0 because it's nearly 45 degrees.
You're right. That should be a small number, shouldn't it? Okay.
Um,
All right, but we could get beta and gamma if we need to.
yeah. 1 over root 1 minus, I guess 24 squared over 25 squared. C's cancel. Coordinate distance, this was asking coordinate distance or invariant distances. The invariant distance, proper lengths, proper times shouldn't change in different frames. Well,
I think we're looking at coordinates. I don't
Joe is measuring 7 years on his clock, but Ed is measuring a different uh time that we're trying to be careful of. I hope this is. I hope we're being careful in the right way, though.
Oh, make a space-time diagram showing the motion of Joe and Ed from Ed's point of view. So maybe that was a 7, and maybe this is a 7. The space-time diagram is in Ed's point of view, right? Who's moving?
Joe goes off in a straight
Ed's
line.
staying still. So let me see if this is correct. Let me draw another line here. This line here, right, a horizontal line on this diagram. I want to say that's the line that's 7 years after. Oh, I just drew that instead of. I want to say that line is the line that's 7 years after Joe left the Earth from in Ed's frame, right? That's the line that's 7 years later in Ed's frame. So what am I trying to say? So points B and D are both simultaneous with respect to Ed, right? Ed sees B and D as occurring at the same time.
Uh, D is whatever is wherever Ed happens to be at the time Joe turns around. So I guess we
Ed, oh, yeah,
defined it in that way, sure.
yeah.
But I think that for Joe, Joe turns around after 7 years. In Ed's frame, Joe turns around after way longer.
That's okay. That's okay because that's okay. So I think this is correct. I think in Ed's frame, B and D are simultaneous events, but in Joe's frame, B and D are not simultaneous events. And Joe changes frames at some point here, doesn't he? At point B, he changes his frame too.
Yeah, we have some like instantaneous acceleration.
So let's see. That's Joe's roll line. So if I draw this line parallel to AB, that line there is the CT prime axis. And then there's a line,
Hey, Nico.
where would it be? There's a line over here, which is the X prime axis, where this angle and this angle are supposed to be the same angle. In other words, those two lines are symmetric with respect to the 45-degree line.
Okay.
And those are the lines that Joe's using to find out like what time it is and where he is. I think.
Yeah, so like in these axes, Joe would be still, at least for the first leg of the journey.
Yeah.
Or depending on how exactly these angles work out. Maybe it'd be better if we put our triangle on the origin. But yeah.
Yeah. Good.
It,
Maybe
it's
that would
okay
have
though. It's
been.
probably too annoying to actually move, but GR is definitely goofy.
So I didn't mean to put the X prime axis going through point B. That's sort of maybe confusing.
This was saying AB is 7 years in length, proper time. Really?
Yeah, B is where Joe turned around. Oh, so you can put the 7 there. Okay. So Don, you're
Really?
right. I'm wrong. I was wrong. I was wrong, Don, you're right. This AD can't be 7 years, can it? We know it has to be longer than 7. So maybe
Oh,
the
is
7
that?
goes here.
Oh, that's so weird though. So this would take care of the dilation if we were to solve this triangle. Or like if we
Well, good,
found
let's
side
do it.
AD,
Yeah.
that would do it.
Yeah, I really want to know how to do this with triangles because
Well, this is the it's just this is the ds, that's the dx. And we can just do the uh that thing. I forgot the d on the dt. So it could be
I'm really thinking
49.
this. 7 times 24 on 25.
Uh 7 times 24 over 25. Nico, yeah, this is special relativity. In the book we're reading along with, we're just on chapter 4. Oh yeah, actually, let me. We're reading out of this book. This may be our fourth or fifth meeting so far, and so we're still in kind of
Okay,
like the
wait a sec.
prerequisites. Oh yeah,
Sorry, I didn't mean to interrupt you, but
come
so
on.
7, 24, 25 is a Pythagorean triple. So that's nice.
Oh,
So I
anything
think,
gold?
what does that mean? This side is 7 times 7 over 25, isn't it? No,
And yeah, this is special
that's the wrong.
relativity. We're neglecting the acceleration.
Hey, Dr. Gold. So 7.
Sorry, hey Sage. Uh, I sometimes type because it's a bit easier.
Aren't we getting a negative? This doesn't work, does it? Let's try
uh,
bigger than this.
we
How can this be negative?
I remember the example we were taking absolute values. Uh, Fizzbuzz isn't so sure about the length of dB. It should be 24 or 25 times the length of AD.
Yeah, is that what we? Oh, is it? So,
Oh, Joe's measuring a dilated distance. Is that the issue?
oh, so we were wrong with the setup. Yeah,
Dude, what is
we
this?
were trying to. No, no, I think I get it. I think I get it.
I don't.
We were trying to use Joe's clock to measure Ed's a distance in Ed's frame, right? Yeah, we can't do that.
But I don't get what is invariant and what isn't anymore.
Oh my God.
Special relativity is just a mind fuck. It really is. Ugh.
All right, so why don't we just, I'll tell you what, let's call this, so this is X. We can get through this. So this is, should I call it T? What should I call AD? I'll just call it,
I
I'm just
don't
gonna
know. Just
call it,
slap her in Greek letter on it.
I'll
You're
call it
just like,
T, and this is what it says, this is 25, 20, 24, 25ths of T. Okay, now, now we can go back to your formula, right? Your line element formula. So what does it say? ds squared equals minus
multiply and divide by gamma
c
until it makes sense.
squared plus dx squared. And now which ones do we know? So we know the 7, right? And I got to plug in the other ones. So it's negative. Tell me if I'm doing this right. Plus
Yeah, as far as I
No,
can
it still
tell.
looks wrong, doesn't it? Because I'm gonna get it. I'm
Uh,
getting a negative on the right side, and I'm gonna have to take the square root of a negative.
I feel like we can just take the absolute value. Because you can also define ds squared with the other signage.
Oh,
And
oh, that's
in
right. And
that one
Fizzbuzz
example.
said he likes the other one. Fizzbuzz and Dr. Cook were saying they like to put the negatives in the other place. All right,
And
let's do that.
I think the 25t thing, for us, we would need a C if we're not doing the C equals 1 thing. But
Oh yeah, okay. We're gonna put the C on both of them, right? So I can put a C on this as well, maybe like
I guess
this.
so, yeah. And then I guess the C would need to
Oh,
also
it's
like
just a seven.
show up there.
Yeah,
I don't know if that's a
well,
C.
that's kind of. I think that's why I didn't put it because I just figured these all had C's in them.
Oh, okay. Then we can just ignore the C's. I don't know anymore.
Okay, let's. So what does this mean?
CT is okay then. I mean, T can just be whatever it needs to be, I guess. It doesn't. Yeah. It doesn't actually matter how I think about it. Shouldn't it be common denominator? That one should be a 25
25.
squared.
Thank you. Good. I wasn't happy with that at all.
So it's still negative. Interesting, but I think we're okay with that. Or I think we're just going to ignore the negative.
Sure. So 24. So that's 49 over 25. I just checked it on a calculator. So I'm going to circle a negative sign to remind myself that I don't know what's going on. 49 squared. It's not a good way to write it, is it? 7 squared. So T is 25. Is that right? Yeah, because then we get, so let's see, we get this. We get this. We should have been able to see it. Once I saw it was a triple, we should have been able to see it. So it's 24 here and 25 here.
Nico, we're just ignoring the negative because I don't think it's important. That's the theory.
Nico, don't you see I circled the negative sign here? That means we don't know what's going on. So here. Sorry, I'm silly.
It's gonna remind me of an electron. Thank you for the follow. So what?
You know, I would prefer to stick with. I don't know. I mean, as long as I understand it, I guess that would be good. But I don't know where the negative sign went. I mean, I agree with Chad. I don't know where the negative sign went. Did we? Maybe that's something I probably got to ask Fizzbuzz.
Oh, 20. Okay, 25 is the distance Ed or the time Ed measures because I got gamma as 25 divided by 7. So if you multiply the 7 years, you just get 25.
Okay.
Okay. That
Well, that sounds
helps a
good.
bit.
Now it's tempting, right? Because what I want to do now, I want to say, okay, if that's 25, I want to say the next leg of the triangle is going to be 50 and just say it's 75 years versus 21 years. But can we do that? Or because he changes his velocity, I think it changes the stretch of it changes the way the frames work with each other, doesn't it? Like if he cuts his time, if he cuts his speed in half, I don't think that cuts Ed's. I don't think that doubles the time in Ed's frame. So I don't think we can just take this 25 and, you know what I mean? I don't think we
I
can
think it
just say that
does.
means
I
that.
think it's going to be
Oh, you
another
think?
50, but we can work it out because Joe's
Okay, let's.
measuring 14 years. And if we go by the gamma thing, that's going to work out to be 50. But we can check it with the triangle thing.
Okay, but wait, don't we have a new gamma? That's what I'm saying. Like if you
Oh, you're right. We do have a new gamma. Never mind. Okay. Yeah, let's go. I guess we can do the same thing with triangles, right?
yeah, let's try
We
it.
know. And this time we don't even need a variable. Because we know that the shared side is 24. That, ugh. 24, 14. All right. So that's going to be 14 squared. I guess I'll just call that one t again. Minus t squared plus 24 squared. Theoretically.
Actual education said God is mayonnaise. I'm sorry, I'm catching up on chat.
um, so this is going to turn out to be 24 squared minus 14 squared, and we're going to square root it. Square root 24 squared minus 14 squared. Oh, that's an ugly number. 2 root 95. I mean, well, maybe I made a mistake with the 24. That would be measured differently when we change speeds. Maybe I shouldn't have done that. Maybe it needs to be, we need to go back to 20. Is it be 12 over 25t now? Because he's going half.
Oh, yeah, maybe.
So that's kind of the triangles look like they share a side, but they actually don't, I guess. Or
Really?
not, they're parallel but not the same length. That's great
Nico
news,
says we went
Lucas.
off track.
That might have been before I fixed it. I mean, I
Oh,
might still
okay.
be off track, but hey, Jesu. I don't know, because at least now it looks the exact same as how we did the first one, so uh 12 squared over 25 squared. T squared.
It's funny, isn't it? It doesn't seem like hard stuff, but it's just like you don't know what you can trust.
Yeah.
It's kind of like when you're good at algebra, then you start learning abstract algebra, and you're trying to do things, and you're like, wait a sec, you might not be able to do that anymore. And that's what this feels like too, with like plain geometry.
Oh yeah, like commuting, stuff like that.
Yeah, yeah.
That's even uglier. Um there's no numbers in abstract algebra, don't fall for it. What is happening? Integrating tangent x? I think it's integration by parts, but there isn't that easy of a way.
We're pretty sure we're solid on the 14, right? I mean, it has to be 14 because wouldn't that has to be the
Uh,
proper time, doesn't it?
oh, maybe is the distance different? He traveled different distance when he changes his speed. Maybe it's not. I,
Is there any way it could be a different distance? I mean,
I think it
so
can.
he's out somewhere in space and he turns around in his rocket ship and comes back at a different speed. It can't be a different distance, can it?
Ed measures the same distance. I think Joe measures a longer distance now that he's moving slower. He's not as contracted. I think the
What?
14 can't be trusted.
Really?
I Yeah, because I'm thinking about like it was a few weeks ago, but Thunderfix asked a special relativity question involving like a proton being fired out of a particle accelerator, and like if you're on the proton, you measure a shorter distance between the accelerator and the target. And if Joe's the proton and he's changing his speed, he's going to measure two different distances, I think. Oh yeah, that is the easy way. Oh my, so the 14 I don't think is a thing.
Really?
Ugh. Um, what do we know? We know his
Yeah, what do
speed.
we know?
We know that Ed measures the same distance. So maybe we need the distance Joe travels measured by Ed in the first leg. And then we uh, are going to contract that for Joe's new speed in the second leg. And that's how we could get the proper time. Unless there's another approach entirely. I don't know. They're over. Okay, you tell me how to underthink special relativity. I would love to think less.
Oh, is somebody here to save us?
Hello?
Oh, Fizzbuzz.
I
Do
can't
not
I can't help
take it.
myself.
Yeah.
So hold on, let me get Excalibur open. But yeah, I think there's a definition problem. So the well, let me open up stuff.
Have you been following us? Do you think we're on the right track at all?
Well, so depending on what definition you use, you can do the 14 thing. It's probably not what the problem is referring to.
Okay.
So like it makes sense to maybe define stuff like, you know, is the speed measured in Ed's frame or in Joe's frame? And that's not really well defined, I think. But if we did,
I guess it's in Joe's frame based on what it says.
yeah. So I think the book probably meant in Ed's frame. So he travels back as measured in Ed's frame at 12 over 25 C.
Okay.
And then the proper time will be what? It won't be 14. But I just wanted to go over. There's another thing here that was done slightly wrong. So if this was 14 and this was 7, right?
Hmm.
We got this is 24. This is 25. So
Yeah.
you can still do this. It was calculated a bit wrong though. So for this triangle, if this was like T2, we would have negative ds squared, which is 14 squared, equals negative T2 squared. And then we have the plus convention, so this is plus 24 squared. So then this means T2, these are not subtracted, these are added.
Huh.
And this is still an ugly number. And this is probably not the answer that's intended. But this is how you would solve it if it was. So all the geometry does still work.
Why is there a negative on the 14 squared there?
Because this is a time-like interval. So if we have like if we just had this, this is time, this is space. And let's say we had this interval, right? The invariant length of this, I'm going to put a negative out here because this is negative, this is some time. This is some negative time squared. Right, so this green line is being a time-like interval. With this convention, we have to take
Yeah, okay, we're
ds
moving
squared to
further
be
in time
negative.
than space. Or no, I think.
I think I
Yeah.
get it. I think I
Or,
get
Yeah, it
it.
is
yeah.
further in time than space, yeah.
I think I get that because didn't they say like if ds squared is 0, that's when you're traveling with light at 45 degrees, and when ds is negative, it's time like, and when ds is positive, it's space like. Is that what they said? That's how they did it. So
Yes, yeah.
you're saying we got to think of time like um intervals like that as being as having a negative length, a negative length. So a vertical line has to have has to be
Yeah,
oh,
yeah.
but then you put oh I see, but then
Well,
you put a negative on it to make it positive.
so yeah, we have to distinguish between some books treat it as like an imaginary length, which is kind of old-fashioned and it's not really helpful, I don't think. Right, because imaginary squared, that's how you get the negative sign.
Hmm.
The way that I prefer to think about it is just that there are two different conventions, right? And that corresponds to whether you have a hyperbola like this, right, or whether it's like this.
Yeah.
Basically, Lorentz boost means you can never take one of these into the other.
Okay. Yeah, I think I understand that. You can only make a like a y parabola, a more skinny y parabola or a flatter y parabola, but it can't change into an x one.
Like, yeah,
Yeah,
choose
I
one
think
convention
so. I think so.
and stick with it.
Yeah, exactly. But like, yeah, the light cone thing, like the light cone really separates these regions from each other.
Right.
And so that's why like sort of complex numbers are never forced to appear because you can never, the complex numbers would appear intrinsically in some operation that like turned this hyperbola into this one.
Okay.
Right? That would be some super weird operation. And we basically never allow for that in special relativity. That would involve like faster than light stuff. But yeah, so the problem with this and why this is probably not what they intended is because then, the speed at which Joe is returning in maybe some weird measurement Joe made, right, would say, well, it took me twice the time to get back, so I must have been going half the speed. But in our frame, we're going to measure, velocity is going to be, maybe we'll call this velocity 2. This would be like 24 over T2. Which would be some weird irrational number. Actually, we might as well calculate this. So I get that this is equal to 0.86. Right. So then the question is like, did the question mean this? Well, probably not. I would assume it probably wants you to assume that V2 is 12/25.
which is quite a bit
But-
different.
Yeah. But I would say that's an assumption. That's a thing that's not specified in the problem.
Yeah. Okay, so it's just how we interpret what the statement said.
Yeah,
What-
exactly.
Well, yeah, as soon as Joe starts going 12/25, like we need to remeasure things, don't we? Or like at least Ed would still measure the same, I guess, distances, but Joe was measuring a different time, maybe a different time and almost definitely a different distance.
So yeah, and this gets into like Einstein's original papers really address this well, because it says like we would have to get into like, how long does Joe burn his rocket engine for, or like what coordinate system are we using to measure stuff. And if it is 12/25, or excuse me, yeah, 12/25, this would imply like you would have to set up some coordinate system beforehand. There's a whole, it's called the Einstein synchronization procedure. So you would like account for all of that measurements and come up with an excuse basically to use Ed's frame for making that measurement of velocity. So maybe I could like coordinate this off with the dashed line, right? Dashing takes too much time. So this could be, assuming this, what should I call this? DS, maybe I'll call this S2. Assuming S2 squared equals 14 squared. This is one thing, right? But a different assumption that they probably want you to make is assume V2 equals 12/25. Right, and in this case, oh yeah.
I think we were assuming both at the same time, but it seems like they're not, like they're exclusive.
Yes, exactly.
Okay.
Yeah, but in the green case, right, you can immediately assume T2 is 50.
Just because geometrically, or wait, like we know that the distance on the, maybe it's bad to use the drawing in red, but like just the T2 distance, we can still know that's twice of 25.
So this would be the distance, the delta x is 24, and we divide by V2. Nico is saying no, you don't get the time dilation anymore. So I'm assuming that V2 is measured in the frame that never accelerates.
So that 24 is being measured by Ed.
Joe was
Maybe.
at point B, right?
Yeah, that's where he turns around.
Well, so So the 24 is a space-like interval. That point, like dB. So there's no, you can't measure it with a clock, right? But yeah, you would have to be an EDS frame, and to turn it into a physical measurement, you would have to worry about some coordinate system stuff.
Okay.
But so yeah, measured in EDS frame is fair to say.
Okay, then I can see why T2 is 50 then. Gosh, this is such a headache of a problem.
Nico says drop the link, I'm jumping in.
I don't just want to put it out there because people have jumped into my scala draws before and drawn bad things, so
Yeah.
I'd rather not have a repeat of that.
Well, it's so I don't quite see what the issue would be, Nico.
If I
But
calculate,
the yeah.
I was gonna say, if I calculate T2 based on how you did it in the part you circled in with the red circle, square root of 14 squared plus 24 squared is about 28, roughly 28.
Mhm.
So doesn't that seem small? Why is that? Why does that seem small to me? So in Ed's frame, so 25 years for Joe to go out in Ed's frame, and then only about 28 years for Joe to get back in Ed's frame. I guess that's just how it works. It's all weird to even to begin with, so I guess I just have to assume that's okay. It feels like it should be, it feels more like it should be like closer to a 2-to-1 ratio, doesn't it? It feels like it should be, but
Yeah, and so if the speed was like if we had a factor of epsilon floating outside everything, and then we took epsilon go to 0, we would get back additivity. So what I'm saying is if instead of 24 over 25 it was a small number, right? If it was 24 over 25,000 or something.
yeah. Yeah, but it's not a small number. It's not. It's close to 1. And so,
Huh.
yeah, I still didn't quite catch the difference between what was in the red circle and what was outside the red circle. One of them was basing the half speed on Ed's frame, and the other one was using half speed based on Joe's frame, right?
Yes. Yeah, and so Joe being the accelerating one, if we just assume that he travels away from Earth for 7 years at speed 24 over 25th, and then we assume that it takes him 14 years to get back, then we get one result, right? That would mean, like by assumption, it would take him what 21 years total, right?
Yeah.
But that's probably not the assumption that it means. I just wanted to demonstrate that like you were doing something correct.
Yeah.
It was with assumptions that are not necessarily like spelled out in the problem, but it would be fair to like chug through all of this and say like, well, this is a more sensible way of looking at it.
It's just, yeah, it worries me that actually no, we don't get the same result either way, but it makes sense to me if we need to start from the velocity and work everything else out again, and not just mindlessly say that S2 is 14. At least to me.
Yeah, exactly.
Okay.
And then it's a really small difference. So we have basically the same diagram. So I'm drawing below the red region now. Okay, so this is still 24. This is still 7. What was this, 25? Yeah.
Yeah.
So now this, assuming this velocity, this is going to be 50. What did we call these? A, B, C, D.
Yep.
And now all you have to do is solve for CB. And this,
Okay.
as a proper time, plus 7 years, is going to be the total time elapsed for Joe.
Okay, let's try that. So
Yeah, so this would be like negative CB squared. Oops. Negative, right? This is dt. Plus 24 squared.
this gives us about 43.8, 43.9.
Cool. So then that plus 7 should be
That feels like maybe more like what the problem had in mind. Maybe.
hit. Yeah, now I'm gonna be awfully embarrassed if the back of the book says something different.
Well, we can always take a peek, and if it starts out along a different route, we could come back and fix things.
Roo. But at least, well, so it's nice that like we can still draw pictures like this and they're just geometrically true, right? So I'm not when we define the problem, we have to be really specific about what frame we're in. When we solve for different side lengths, we can just use these triangle formulas.
Yeah. It would be good to have a geometric sort of, what am I trying to say? It'd be good to be able to draw these triangles and use it as a shortcut. I'm going to have to pay attention to the negative signs, obviously, but that's nothing new. I've been struggling with negative signs for, my whole life.
Yeah.
It feels like every branch of science, or engineering, no matter what I'm doing, always the negative signs that kill me, like going and trying to close a loop around and use Kirchhoff's voltage. It's always the negative signs, no matter what I'm doing, it's always negatives that are jumping out and going the wrong way.
But what we have here is good, right? It's like CV is about 43, and we could do that plus 7 and then get the difference. Like, this seems okay to me, at least.
Yeah.
Doesn't mean all that much, but...
So I'm happy to. I don't want to go off and keep explaining without like questions. So there, right? One issue was the assumptions, which can be
Mhm.
taken like, yeah, to mean different things. The other issue was consistently dealing with the triangles. So making sure that the time-like intervals are measured with the same sign. So that was the sign error that was going on.
What do you mean the same sign? You just mean if I have an equation and there's time-like intervals on one side and the other side, it should have the same sign.
Yes, yeah. So like
Yeah,
in that
okay. I
equation,
think that,
CB squared and 50
yeah,
squared have the same sign.
let me scroll up here. So if we scroll up a little bit to where I drew the first ABD triangle, and I wrote ds squared equals negative c dt squared plus dx squared. You're saying I probably should have either put a negative over here in front of the ds squared, or I should have changed all the signs on the right-hand side of this equation. I
Yeah,
probably should have put
yeah.
I should have put a negative in front of it, shouldn't I? Can I make it
And so
red?
should we always
Oh.
do that when dealing with time-like distances?
Yeah, yeah.
Okay.
So does that mean when you look at the diagram, you have to know ahead of time, basically whether your line is inside a light cone or going through the side of a light cone?
Well, we know that based off the speed. As long as it's less than c, we're okay. Or we're inside the light cone.
Yeah,
Yeah.
exactly. And that's invariant. So if something is at a slope less than 45 degrees, it's always going to be less than 45 degrees.
Nico says 40.95 years.
I think that's what we got, right?
How many years for Joe, Nico?
Oh, for Ed,
Ed, we're saying
Joe, yeah, I
75.
think.
Joe 50.86.
Yeah, we were getting 75 for Ed, right?
Yeah.
Well, I usually don't like looking at the answers too quickly, but I'm kind of champing at the bit for this one. I kind of want to see what they did.
Yeah, I want to know too.
Did we finish it or is there more to do? I feel like we've finished it.
I feel satisfied with this. Number 9. The triangle looks similar. That proportionality, like the 25 to 50, is the same. The
Oh, they just said
bottom,
right away TL and
25.
2TL. Is that what they said?
Uh, or
Yep, yep.
T1 and 2T1. Or it's like
T1 and 2T1.
it's
Okay.
it's just like twice of the time that it measures, which we said the same thing. Uh,
So they are saying 75 years for Ed.
yeah. And that makes sense from Ed's point of view. We never gonna like just observing how fast Joe is going.
I'm not quite seeing the right side of that page on the stream.
Oh, is it? How did it get like that?
It's just cutting off a little bit on the right side.
Yeah, I see that. It's been like that for a while. How the heck?
Oh yeah, there it is. There it is.
Yeah, but now I have that black box there. How was I fixing that? I'm gonna have to work on that, but I'm just gonna keep the black box there for now.
Looks good to me. I don't see any black box.
Like on the bottom of the screen.
Oh, yeah, I see it. Yep.
That's annoying.
51. Okay. 24 years. That's okay.
Yeah, and we got a difference of 24, 0.14.
Yeah. So they,
I think it tell too. So they take the time measured in Ed's frame and multiply it by the gamma. So they give the triangle, but they don't really use it, as far as I could tell. They just use gamma to convert times.
and all the numbers they're giving us are years. So instead of thinking of the sides of the triangle, and we've been doing that, haven't we? All the numbers we're using here. I wanted to think of all these lengths, the DS's, as being like meters. Maybe it doesn't matter, like you said, Don. I could just multiply all these numbers by 3 times 10 to the 8, and then I'd have meters. Right? Why would I want to do that? That would be awful. I think,
Yeah,
wasn't it
I think
Dr.
next
Cook was
chapter these are
saying
going to
that-
be in meters.
Oh, okay.
I think they're just maybe keeping things simple. Like gamma is unitless anyway. I think it shouldn't matter, at least for chapter 4's context, whether it's actual time or distance.
Ah, and they used the letter tau there, didn't they, for the diagonal side? So tau
Yeah,
is
proper
like
time.
proper time. Okay.
That's something that I've learned though, that like the diagonals of the triangle or like the hypotenuse, whatever, would be tau, like the proper time.
Okay.
Wow, that what a problem.
No, that was good.
Yeah,
Good.
we definitely learned something there. Fizbus, thank you for jumping in on that to save us.
Yeah.
Yeah, I hope I made some things more clear and not more confusing.
Thank you for.
No, it
throwing
was
us
very
a
good to hear
life-
that we
a
shouldn't.
a life raft.
We're making a bad assumption. Yeah.
Yeah, and okay, can I?
We
one
were
more
close.
thing?
Yeah.
You know, we were fumbling our
I
way
can't
there.
help
I feel
myself.
like we were close.
Okay, so you have this diagram, right?
Yeah.
And I love doing this. So let me actually redraw this. Okay. If you imagine a Lorentz boost, let's see. Both of these are time-like. So you could imagine drawing two hyperbolas, and when you boost the frame, maybe I'll do green. You're gonna boost somewhere. This would have to be less than 45 degrees, but you might. This is really bad, but you would basically have some similar diagram with all of the edge lengths the same. So all of these intervals, like if you wanted to solve the problem in some bizarre frame like this, you would have some super bizarre diagram like this, but it represents the exact same thing. What you have to keep in mind is that like it's just like you're in the Euclidean plane and you've tilted your head, right? Meaning you've applied a rotation matrix to everything.
Yeah.
That's what hyperbolic rotation would look like?
Yeah.
Oh my god.
So you have to, instead of like tilting your head, you do the squish stretch stuff. And you have to like pretend you're warping your brain so that the green triangle and the black triangle are the same.
Wow.
Right?
let's-
It's
let
totally
me-
the same geometric object.
So point A was fixed because that's like the Earth. And you're saying like point B and point C are on hyperbolas, right?
Yeah.
This
Yeah.
is from some third inertial observer that's going at some other speed, I think. The green triangle.
Jet, what do you mean pretend warp your brain? Yeah, that's fair. Yeah, and you could include translations as well.
Oh yeah, but those will just behave as expected. Those won't be like mind warping, I think, right?
Yeah, yeah.
Okay.
But it would be like, two triangles are similar if they could be warped into each other, right? But then the super weird thing would be like this triangle and this triangle. Well, maybe I should draw it like this so it's not a reflection. In hyperbolic space, these are not similar,
Oh, the distances are
right? Where
different? Is that why?
well, it's because
You'd
there's
have to-
no Lorentz
you'd have to-
transformation.
Yeah, you'd have to like go through. You
Yeah.
have to do what you were saying before, like multiply by I or something to get one of those to the other one.
Exactly, yeah.
And that's not allowed.
Yeah, a Lorentz transformation with like speed equal or gamma equals some crazy thing.
Oh.
No, this is good. I gotta find some YouTube videos to watch about this stuff.
Yeah, they've got to be out there. We could make one. We could we could write a script.
That's true.
Well, you say we. I think you mean you.
Well, you saw how clear or unclear some of my explanations are.
Hey, you just do this on the spot though. So
Yeah, the impetus and the feedback would be good
yeah.
if you want like more explanations and stuff like this.
I watched that video that Dr. Cook put in the reading group.
Oh, the
channel.
train one?
Yeah, the train. Did you watch that, Don?
I started to. The visual's just a little bit too like goofy for me. I couldn't stick with it.
It wasn't too long. It was only like, I don't know. I don't even think it was 15 minutes. But the first part was kind of cool because it explained how from the two different, it was the question we did last week, right? With the barn with the pole. It was basically that, except it was a train going through through a tunnel, right? And if the train was going really, really quickly, then in the train's frame, the train seemed longer than the tunnel, but in the person's frame who was standing by the tracks, the train seemed really short and the train fit in the tunnel, right? And so that was kind of good because they explained how from the 2 points of view you could, but then what they said was, so they said the woman watching, she could imagine both sides of the tunnel closing up and the train would be able to fit inside. And that was because it had been Lorentz contracted in her frame, right? And so that was fine. But then they said in the person riding the train, in their frame, they see the train as longer than the tunnel. But they said the physics has to be such that if the person outside can see the whole train fitting in the tunnel with the two sides closed, then that means the person riding the train has to also be able to see that. Then they said to explain it, you have to imagine that the train's not a rigid body anymore. The train's like you can separate it into all these different pieces that are like, like it's a big spring or something. And they said, okay, you're going to close the front and close the front. The front of the train's going to hit the barrier, and then it's going to like start to collapse on itself like a spring. And you're going to be able to put the back door closed once it's like contracted inside there. And I thought this seems like bullshit at this point. Like I couldn't believe that for a second.
Oh well, yeah, I guess it's not the reason for length contraction, right? But if then you change the question to like they're like instead of two barn doors, they're like two blast doors, right?
Yeah.
Yeah, then that's a weird thing.
Yeah, it was weird. And then they said, okay, the third thing they did said, now you got a monorail. And they said, in the person's frame who's watching, the train looks really short and it's shorter than the gap. So it's going to fall down into the chasm, right? And then they said, if you look at it from the frame of the person riding the train looks really long and the gap looks really short. And they're like, oh, well, the train will just go by. But no, what happens is, again, the train falls down into the chasm, but it goes down into it like a slinky, like all the little pieces of train, like sort of, it's like it's a coil or something, and it falls down one piece at a time. It was really weird, and I was like, I didn't
I
understand
guess I
that
gotta
at
go
all.
and watch it. That sounds kind of hard to believe. Yeah.
Yeah, check it out. It's only like 10 minutes. See what you think about the stuff at the end.
Okay.
Have we got time for one more, or are we getting close here?
I have a minute 53 on the uptime. We could try for another one.
What
Uh,
was it? What was the next one you were thinking of?
12. It's another kind of geometric. Uh,
12 looks okay. We've talked about this. Show explicitly that the straight line path between any 2 points in flat 3D space is the shortest distance between them. Oh, well.
we might need to go to like the functional thing for that.
Yeah, we got to use the Lagrange, Euler-Lagrange thing.
Or wait, was that in chapter 3? Uh, I don't. Hmm.
That was, I think they did that at the end of chapter 3. Yeah,
I'd be in
they
chapter
talked
4
about
then.
that.
Maybe in chapter 3 we didn't have the. Oh, we didn't have the dt squared yet.
Yeah, that's right.
So could we just check that it satisfies? Well, wait, how would that satisfy the Euler-Lagrange? We need to say what L is. Wait.
I want to say Dr. Cook did this 2 weeks ago, didn't he? Didn't he show us how to do that?
Oh, maybe he did. I'm bringing up past whiteboards. I definitely remember him making us check something in the Euler-Lagrange equation. Oh, using the arc length formula. Is that it?
Yeah, this thing.
Okay.
Yeah, there it is.
Isn't this just math? Probably, Nico, yeah, but it's math we don't know. Or at least are only just now learning. Um, why are we doing? Oh yeah, so we're saying that our L of f prime x is equal to root 1 plus f prime x squared. How do we know? If I didn't have that, I don't think I would have known to do this. Then I guess maybe I won't repeat every last bit of math here, but Um,
So we were doing that for the one-dimensional case, weren't we? What if it's three-dimensional? It's, I
oh,
mean,
uh,
Yeah, so you can do it for multiple variables.
okay. So should we
Um,
maybe do L of X, Y, Z?
yeah, you can do that. So this would be um I tend to write it like well so we could write x of t, right? Or we could write x of s, which is probably better for a relativistic setting, because then we would have t of s, x of s, y of s, z of s.
S is just some parameter?
Yeah. Um,
is that proper time?
you can choose it to be proper time, yeah. And you usually do. You don't have to.
Okay.
Um, but I guess for 12a, we can start with x of t, right? So there we're gonna have L x y z x prime y prime z prime um, is equal to this squared y prime t squared z prime t squared. And then yeah, Euler-Lagrange equations. Oh no, error.
Yeah,
Anyways,
we just ignore its complaints.
dl over d x prime. All of these are going to be equal to 0. So it's really no harder than what you already showed, just more variables. Right, and then really we don't have to evaluate the d over dt. We can just say, what is this? This is going to be x prime of t over, this whole thing. We could just call the velocity equals constant.
So is the right-hand side of the previous line 0? Is that because nothing here depended on? Um, is that because the Lagrangian didn't specifically depend on time? No. Is that why?
On time, yes. So I could have added a t here. Um, that could have changed things, but then also it didn't depend on these variables.
I was
That's
just
why. Yeah.
looking,
Thank
yeah.
you. Thank you. Thank you. Yeah. Because the right-hand side is is partial ddx, right? Of L.
Exactly,
Yeah.
yeah.
Okay. 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 I got you.
But yeah, so this argument is you know, you take this implies x
All this.
prime, y prime, z prime equals constant, which is a straight line.
And so yeah, I think from there basically the math that we did, I think 2 weeks ago. just more equations, but the same manipulations.
Yeah.
And so then the question, right, for part B is, it's something I've heard Don say before, so I
Yeah,
know
we
you've heard
know
it.
we know B is false because is no. The answer is no because we've seen. I mean, we've done examples where. So, for example, if you had this, here's the one they showed in the chapter. If I draw a triangle here, if I got my pencil here, am I here? Yeah. So if you had this, this, and this is the one they did, where this was 90 degrees, and these lengths turn out to be 0 because they're like light, the way light goes. Am I drawing in red? I think I am. That's fine. So if this is A and B, then you can get from A to B through C, and you can have a metric of 0, right? But if you go straight from A to B, this is greater than 0. Does that seem right?
Yeah, yeah. And so then if in the Euclidean case, we justified it on the shortest distance, right? For
Yeah.
12b, it's an extremal distance. It's not necessarily the shortest though, right?
Yeah, didn't we say that a few weeks ago? I remember saying that to Don, or Don said that to me. But we said the longest distance between 2 points is a straight line.
Yeah, exactly.
Can we put axes on this triangle? Or I feel like things would need to be rotated. Because if there's space like separated, we would
Yeah,
want a
my
point like from there to there, wouldn't we?
Yeah, yeah. With that convention, it would be less than 0 with negative delta t squared.
Um,
Meaning line AB. AB would be.
AB would be like the one that I drew here. And so, yeah, like if we go,
wait, you're don't tell, you're catching me on the sign again, aren't you? So this is less than, wait,
Yeah.
this is less
I'm
than
just
0.
confused by the rotation of things.
All right, I got you. Because that was a time like, so we call that negative.
Yeah, this would have a positive.
But if we were down
ds.
here, we could go like this, right? And then that. Okay, I see.
Yeah, yeah. To be really precise about it, I guess we could write usually g is the metric function. So I would write this as like g of AB vector AB vector is less than 0.
Okay. I think they start doing that stuff in the next chapter.
Okay, yeah. Yeah, it's kind of weird because this is like if you studied vector spaces and inner product spaces, basically all of those, almost all of those theorems hold for this inner product G. Even though it can be negative, it has most of the properties that are.
I hate that it's the word
necessary.
almost though. It's the little bit that's not there that scares me.
Yeah.
That's why
But I'll tell you what the
one.
the thing is positive. Oh geez, not positive definite. Crap, I forget it too. I forget it too because I only I've only been tested on all the vector space and inner product space axioms. It's like non-degenerate metric, or instead of metric, right, inner product. So basically everywhere that like in where an inner product would be defined as positive definite, right? If the vector is not 0, then its inner product with itself has to be greater than 0.
Yeah.
We lose that,
Yeah.
but we get non-degenerate, which says that if the inner product of g of like x, y, say this is for all y, this is true. This is true. I think it's, yeah, if and only if x equals 0. But like this property takes the place of being positive definite. I guess it bugs me, and I feel the need to explain this because it's not that much different from inner product space. It's like one tiny change. And most places where you assumed inner product stuff in linear algebra, you can assume this instead, and the proof still goes through. Okay, well,
Because I haven't really ever learned about like the generalized like inner product stuff, so I only know thing in terms of like the dot product with vectors and like a couple other like small examples that I've seen, but
okay. Well, yeah, I mean the dot product is an example of it.
yeah. Okay, I guess that's
Wow.
a little past the 2 hour mark, but anything else?
I looked ahead a little bit, I got to admit. In chapter 5, they're dealing with 4 vectors. And they were talking a little bit about scalar product and then they were getting into momentum and stuff. So I only read about 10 pages, but it was getting confusing.
It's
It was getting confusing.
I've read through I
That'll
think
be
most of up until like some point through 5.3, and I was very lost.
yeah,
Chapter 5 is
that's
going to be
about where I
hard.
got to. Yeah, it might be.
Nico, part B was not Euclidean. Only part A was Euclidean, I think.
Yeah, chapter 5 is good stuff.
Nice.
Feel free to ping me if you're like really stuck on something.
Okay,
Okay.
thanks.
Um,
You might regret saying that.
yeah.
I
um,
might. That was one of my favorite parts of TAing is like when it's like 1 a.m. and I get an email and I'm like, oh, I should go to sleep, but actually it's a really interesting question. I just like reply back to a student at 2 a.m.
oh yeah, like the thing like u.u is -1, and like that gets applied in other things for other facts. I was trying to do like there's some parts where they said, oh, with some simple calculations you get to this step, and I tried to do those calculations and I couldn't. So if I can remember which one it is, I might ask you about them. I suppose.
Okay, cool.
Yeah. Okay. Thank you for
All right.
for
Thanks, guys.
rescuing us. Yeah.
Yeah.
Yeah, it was my pleasure. Thank you for hosting.
Yeah. And $10. Thanks for being here.
Yep. See you
Oh
next week.
wait, do we want to do chapter 5 next week? I think we just like push forward, right?
Yeah, it's fine with me.
Okay, then yeah,
Yeah,
let's plan
up to you.
for. Okay, yeah, that'll be the plan then for better for worse. All right,
Sounds good. All right,
All
see
right.
ya.
see you
Yep.
guys.
See you guys then.
All right, another reading group. Just gonna take a few minutes to switch things over. Going to just a normal like math stream. Um, yeah, for anyone, it looks like we've had a couple of new faces pop in, and it's always hard to get a word in because I never want to cut off the discussion that's actively happening. Those guys I'm sure knew their stuff. One of them did. uh, for anyone who's new here, these are the streams that I do on Saturdays for about 2 hours. these streams are special, are about a reading group for special relativity. So I'm learning this for the first time. Fembox fan is learning this for the first time, and then FizzBuzz, who's right there in chat and also streams. And sometimes Dr. Cook will hop in, and those who actually know physics, and they will help us out. But the normal theme of my stream is taking math questions from chat and trying to help people out with things that I actually know how to do. Hopefully I actually know how to do them. Usually people ask me really difficult questions that like two people on this earth know how to do. That. Okay, all my stuff is updated, I think. Let's pull the image. And let me do a little Discord announcement. Notes for chapter 4, part 2. Let's start on chapter 5 next Saturday at Reading Group. Okay. What's happening in chat? Yeah, that was FizzBuzz there, who jumped in partway through to rescue me and Fembox. Jasu is getting a PhD and coming back around for another degree. And Nico, I meant to ask you, but it was like a little bit hard to like have a conversation. Do you stream also? I do not care at all about self promotion. So if you're someone who streams math or physics or something similar, like I always want to know. I mean, you don't have to share if you don't want, but I'm always interested to meet more people who are doing stuff even remotely similar to me. Darth Mike, hello, welcome in. Okay, ND Vines, how to not be depressed? Be a therapist, I guess. I'm not qualified to answer that question. Oh, like co-working, okay. That's like, because Famished recognized you, and Famished is in like every stream that's even remotely related to math, I feel like, so. But yeah, if you're interested in getting involved in the reading group, I'm not sure that's you often in the Discord, but we have a channel for the reading group in the Discord server and a role for it. If you want to actually hop on the call and be able to hop in the Excalibur, like we can arrange that. $7.50. Hey, fake relationship feels like drowning beside someone who promised to teach you how to swim. Damn, that feels like the lyrics to a song. Um. If you want to be able to be on the actual voice, I would need to give you the role for it if you're interested. So you just like tell me and tell me like if you're Nikolai who just joined the Discord a little bit ago. Manal, no worries. It came up on your test. Oh wow. Glad I was able to help. That is you? Okay. I'll give it to you, yeah. Is there an easy way I can do this? Can I just right click on your name? I can't. Okay, so we do this on Saturdays starting 2 hours and 15 minutes ago, but you should see that reading group voice channel down there now. That's where we meet. In the this is the text chat that everyone can see. If you want to get pings for the reading group, that's in channels and roles. Just hit that one right there. Yeah. You said that you're a first year uni student? When I started studying physics? You want a fake husband who is ideally a gay billionaire? Fair enough, Jasu. Yes, again? All right, nice. Well, it's good to meet you. Okay, let's clean up this PDF. Yeah, there's a whole niche of math and physics streamers. Um, that's those people who I can recommend who all do like math help in some way, who I've known for the longest. There's also relatively newer streamers like Academy's Ideas and Math Spellbook. So you don't have to like follow every last person there if you don't want, but I just like to let people know that this niche exists. Um, I seen playing math. Oh, I should change that phrasing, shouldn't I? Yeah, I'll have to think of a better phrasing. We don't play math here. We're serious. Um, I'm debating what I want to study here. So if anyone's a question I want to ask, let me know. I'm debating if I want to study mechanics or if I want to study linear algebra. Oh, and Island Man. Hey, I never said thank you, but thank you for the follow. I think that was a little while ago. You've yet to find said fake gay billionaire husband, though. I mean, you might want to try Grinder. I don't know where else they would be. I mean, we could even do more relativity studying. So if we're moving on from chapter 4, I can do whatever problems I desire from chapter 4. Let me see what else there is. Just a 12. Hey, Emma Jack. You're not actively looking. Just keep an eye out in case the right fake gay billionaire husband happens to pass by. Oh, you know what? 13 might be a good thing for us to look at after the struggles we were just having. Great. That's good to hear. If you have a question, feel free to let me know. If you're just here to chill out or talk about math or whatever, that's also fantastic. Stranger is not. Oh shoot! I didn't shout out Fizzbuzz, dude. What the hell am I doing? Fizzbuzz tends to do more coding type stuff on his stream, but he's very good with math and physics, obviously. You live across the globe, a long distance relationship. Yeah, I'm surprised. Like, I I feel very strongly that um this type of math help live stream has the potential to really like help people out in a way that, as far as I know, doesn't really exist on the internet. Um and so when I started there were just a handful of people who were doing it. I started 2 years and a few months ago. Uh but over that time there's been a lot of new people who have popped up and kind of like the more people who get into this niche as streamers, the more kind of viewers tend to get like it's like we're casting a wider net, I guess. It's been nice to see that growth. You're not good at math? Hey, that's no problem, Emma Jack. If you want to learn, this is a place, or if you just enjoy the vibes and want to hang out, that's also fine. You would take a fake gay billionaire husband who lived across the globe? Yeah, I think we all would. I mean, I I think you should also if you're going that route though, I think you should add on the qualification like terminally ill or something. Like it could be a long time before you actually cash in on that. You'll take two, yeah. European chemistry makes you want to leave everything and be a saint. Hey, the only thing stopping you from doing that is you at ND Vines. Where's it down? Exactly. Should have told me much sooner. Both romantic and sexual attraction was something that only happened in movies. Wait, that feels like the opposite of like Jess, if you're saying you want a fake gay billionaire husband, I was kind of like that feels like an asexual or aromantic type of thing to say to me. But I feel like what you just said right there is the opposite. Unless I'm misinterpreting your words. I don't know. It's all a joke anyway. Maybe I'm overanalyzing it. What does 13 say? Inertial frame, two events occur simultaneously at a distance of 3 meters apart. In a frame moving with respect to the laboratory frame, one event occurs later than the other by 10 to the minus 8 seconds. By what spatial distance? I assume inertial frame. By what spatial distance are the two events separated in the moving frame? Very much ace and aromantic. Okay, but yeah, you're saying that if romantic and sexual attraction doesn't only happen in the movies, that means it is happening for you. Or I think you just need to like flip the wasn't to was, or could be, or something. That's what I was confused about. Thanks for the kind words, and Divines. I don't have any plans to stop. Casey, Don does grammar and verbal logic. This will be what I change my username to. Verbal logic, specifically pertaining to jokes about gay or fake gay billionaire husbands who are terminally ill and live across the globe. I think it's a pretty good username. It's pretty easy to remember, right? Oh, I get what you're saying now, Jasu. That makes sense. It was me misinterpreting. Username already taken, true, Matthew. Hope you're doing well, dude. I see what you're saying now. I don't know. Now I don't even know what to say. It turned out that the doll would be about nothing. Just at 69,420. That's when the website is like, we suggest the following usernames instead. Mr. Dondo's grammar and purple logic. 69,420. The Don does grammar. Like those like stupid like variants. Two computer life hacks. Set up buttons to open programs, a chat GPT button, keyboard scripts, let you type special character. Ooh, that Greek letter thing is pretty nice. Chat GPT I don't personally like using. But like the issue of writing math speak in Twitch chat is one that I would love to solve, that I don't think there's a very good solution for it, but like one way that I was trying to at least help with it was having that command so people can copy and paste stuff. But that's kind of far from ideal. That is nice to have all those things like set up like that. What I would want to do this boss. Oh my god, I remember Hoo, one of my mods, was able to make like a bear face out of those symbols or something. It was really cute. I don't remember how she did it though. But the thing that I would love to be able to make is a chat like that one up there, but it renders LaTeX. I think that's like the best solution you could possibly do. Still not ideal, but it's kind of my thought. ChatGPT is dumb. It might be in like ChatGPT isn't perfect, but it's only ever it's going to get better, and it's going to get better quickly. Um, that's capital lambda, yeah. Is there a variant? Or like that's how I was taught capital lambda like that, or like depending on your font, it might look like that. Nightbot? Nightbot is just a bot that'll. I mean, I'm kind of phasing it out, but it just kind of helps with like doing chat commands and stuff. I don't have very much set up though anymore. Is there a different capital lambda? I don't think I've seen it. Gamma is weird. Like, why is that or why is that lowercase gamma, but also that? Like that's just strange. I prefer this one, but I feel like a lot of people like that one. Okay, what's up with this? It's like a cursive thing. Oh, okay. I guess it's the same thing with epsilon as well. There's that and that. Var lambda and LaTeX? Okay. Yeah, I mean, I know that's what it is for like epsilon and stuff. You just put var in front. How do we figure out this Lorentz boost? Or sorry, yeah. We know that one is simultaneous, the other has a slight time discrepancy. How do we translate that to gamma? Like I want to do a ratio, but when things are simultaneous, one of those numbers is 0. Oh yeah, I've seen that identity. That one's like just super strange. I think I've done a mini proof of that from a little worksheet that Dr. Cook gave me a while ago. Hey, RW, Ramon. Yeah, he had this. It's like a calculus worksheet he made for some reason with a bunch of kind of interesting problems that are a little bit outside the scope of a normal calculus class. Um, so like the gamma function was one of them. I forget what else was on there. Oh, like half differentials. I forget what if they're actually called half differentials or not, but like you know, like the half derivative. You started thinking a song for my Spotify started playing. Oh yeah. It's really bad. Like when I raid someone, I usually forget to turn my music off, and I'm like, wow, why does the music on this person's stream set sound so terrible? But I realize that my music is playing over the top of their music, and it's not a very good mix. Slightly tilted. Oh, I guess like in my math symbols thing, it is kind of like that. Slightly tilted. Hey, MMD. I feel like you say hi a lot. It's a little wrong with that, but I feel like each stream I say hi to you multiple times. Okay, the thing I want to use a formula like this, but the issue is that one of these is 0. So like, what the hell? Okay, maybe yeah, sorry, I'm just like jamming out. The Lorenz boost part is kind of confusing, but from the lab frame, this way I was originally thinking of doing that one problem that FizzBuzz jumped in on. But like without like doing this totally divorced of geometry, which is maybe a bad call, but ds squared, just as the lab frame would think of it, is just 9, 3 squared, because dt is 0, dy dz are 0. And so in the other frame, we would know ds is the same because ds is invariant, but these are different. So we have two variables, and that's oh, but we know dt. Aha. Um 10 to the minus 8. The c is annoying. I don't like c. I think we probably need it though, because otherwise it's just going to be 9 basically. You think you might be wrong? Okay. Symbols are nice in programming as well. Python supports it. Really? Python supports it? Oh, I mean, I guess that makes sense. That's why Unicode is a thing, right? I don't know. I don't know if programming languages would do. I don't know how anything works. Um um what am I doing? So this would get added to each side. The other frame is going to observe a longer separation? That doesn't make sense. Shouldn't it be shorter? It's moving. It should see everything contracted. The lab frame is getting the proper length, and the proper length is the longest something can be. If something is moving, it's going to see it shorter. Uh, epsilon character has error. Oh, nice. Okay. I feel like these should have the same sign. That's what I don't like. Well, I'm confused about the Lorentz boosts, though. I don't know how to find the velocity, is my issue with the Lorentz boost. So I was trying to go to the second part. I don't like that dx is longer. You can just see what number we get, but I don't feel like this can possibly be right. 9 square meters plus speed of light times 10 to the minus 8 seconds squared. .241 meters. This makes no sense. It shouldn't be longer, it should be shorter. Part 2 to find velocity. .241 divided by 10 to the negative 8? Well, that's gonna be huge though. And I already feel like my 4.241 isn't right. And also, like, I feel like they do the Lorentz boost thing first. I mean, I guess maybe it should be. You do need a pretty huge velocity to even make that small discrepancy, right? I, I don't know. Oh. Yeah. Oh, is that what I need? Proper time is 0 for us. So I don't know what's wrong with this math, but can I throw it out? And proper time 0, find ds in respect to the moving frame, which is minus 10 to the minus 8 squared plus dx squared, and solve. Hey Aziz. and solve for dx. Theoretically. I'm gonna be honest, Nico. Most of the 7TV emotes I see on Twitch, I don't really like. I just think they look stupid, and the thing I hate the most is when they use 7TV emotes to replace regular words. Maybe I'm just a boomer, but that ain't me. So isn't this just 3? Or maybe 2.98 or whatever? Bruh. I mean, this is more reasonable, 2.998. It is shorter, at least. All right, as long as I'm ranting, the ones that I hate the most are the stupid animated cats. I love cats, but I hate when they are animated to do like all sorts of weird shit. See, that's a cute one, Amidablam. And Fizzbuzz, I like that one too. What I don't like is the stupid dancing cats. It's like they're moving in ways they're not supposed to move. I just don't like looking at it. Or the worst one is like, it's like a bye emote and the cat looks like it's crying. Oh my god, I hate that one. See, like, Cat Jam is fine. It's not like unnatural movement. I guess Fizzbuzz is, that one's at least it's more like cartoony. I don't like it's like an actual cat that's like just stretched in Photoshop and stuff that I don't like. No. I don't even know what those emotes are, Nico, but I'm happier without them. I don't know, man. I just don't get them. I just think they look stupid. Joel teaching his son Joel how to spin while what the hell? Okay, that one sounds kind of funny. Like some of them are good. It's just that at least half of them are usually garbage, in my opinion. Um, so this would be part 2. What would be part 1? I still don't know how the hell you're supposed to find. I don't know, but then like people on mobile can't see them, and then I just don't like having to have a million extensions. Like, are people supposed to have 7TV and BTTV and Franker Facey? It's just so many extensions that can all break stuff and make Twitch run worse. And I know like inside of FFZ you can activate the other two, and I think you can do the same in 7TV. But you have to mess around with settings, and 7TV in particular really tries to make you spend money on it. And I don't like that's just another thing that's like begging for your money. I don't know. With 7TV in particular, I feel like I have multiple issues. BTTV and Franker Facey are at least a little more chill. With like the monetization stuff. Hand drawn. I mean, that's cute though. It's cartoony. I had to find the actual let me see if I can find it. I don't like when it's an actual cat that's being stretched around to do things. It just looks like unnatural, I guess. Oh my god. Like this one right here. Hate it. I don't like the way the cat's mouth moves. I can't find the exact one that I'm thinking of. This one, this one just feels pretty photoshopped on the eyes, and I don't like that one either. Joel is funny at least. Joel makes me laugh. But no, I'm happier with Ellie's. I don't need another thing like begging me for money. Jasu, we're talking about 7TV, which is like an extension you install in your browser to see more emotes. Or like add a lot more than Twitch allows you to add. And I'm going on a rant about how much I generally don't like it. One for the Science and Engineers by Thornton and Rex. A few chapters on relativity, about 80 pages. Oh, nice. I still have no freaking clue how you would find the Lorentz boost in this question. If it's a constant velocity, I could go to the integral thing. Like this? I don't know, though. Or wait, what am I trying to do? I don't know what I'm trying to do. Separation between scientists and engineers. No, Jasu, we're lumping you in there with the engineers, whether you like it or not. But I mean, I guess physicists. Never mind. I was gonna say it's because mathematicians are considered scientists, but that's physics. So we learn the same but are jobless. True. Not true. Okay, most are jobless. Okay, I really don't understand. Wait, well, maybe. I'm thinking. It's not working, but I'm thinking. If you have a time interval in one frame, you should be able to multiply it by gamma to get the time interval in another frame. But one of them is 0. So you can't multiply it by anything to get 10 to the minus 8. And maybe my confusion lies in it's not a time interval, but individual time measurements that get multiplied by gamma or divided or whatever. But I seriously have no freaking clue. What they expect us to do here. That's the equation I need, I guess. So wait, what's happening in what frame? The simultaneous one is the primed frame in this equation. Uh, Gravity by James Hartle. So in my case, 10 to the minus 8 equals gamma v over c squared delta x prime, which is 3. That's how you're supposed to do that. And now we'll solve this for v. That's kind of annoying to solve for v, isn't it? Let's square each side. Like that? Okay. This is such a roundabout way of doing this. Hey, Pervika. Because this is not the final step once I find v. This is all in the name of finding gamma. V squared 1 over c to the 4th plus 1 over 9 times 10 to the 16 c squared. Is this not simple mental math for you, Nico? Come on. I eat equations like this for breakfast. I'm also malnourished. Yeah, way too many horse horses. Yeah, I mean, if I was gonna put money down, it's on me having messed something up here. Oh, Wolfram Alpha's gonna do the units. I don't want it to do the units. 10 to the 16 times speed of light squared. Nothing wrong with this. Is this a good thing or a bad thing? This is the velocity. What is this divided by the speed of light? 70% the speed of light? That feels kind of fast. (2.12 times 10 to the 8). Apprentice stays in every math subject, most stuff top 50, not top 10 math. Best in my country for his age here. Failed to do something like 15 plus 23 in his head. 3 over root 2? Gamma? I guess, yeah, this is a... We're doing this for the sake of gamma, right? Gamma is 1 over square root 1 minus 2.12. It's 10 to the 8. Oh, I don't need the 10 to the 8. .41. Isn't that just about root 2? This is why you took bio. Fair enough. For Pika. Okay. This is gamma. That's what I wanted. But what am I doing with this again? Oh yeah, now I just need to adjust the 3 meters. So I expect the 3 meters to be contracted. So I want to take 3 and divide it by gamma because gamma is more than 1. Damn it. I want to multiply it. Wait, what the fuck? Oh, wait, I flip it there. 2.12. Wait, that feels stupid. Didn't I just get... So I got 2 different answers. What did I do wrong up here? Oh, thank you, Fenlux. Oh yeah, like the Grothendieck prime. What is it? 57 times, or the Grothendieck prime is 57 because it's not actually a prime. Uh, 3 times 19. Okay, you're joking. Okay, this way feels so convoluted down here. This way feels much simpler, but it's for some reason wrong. Fuck it, I'm looking at the answer. It's been way too long on this problem. What it's 13? Delta. It's what? The lab frame is measuring the proper distance, right? Anything else gets contracted if it's moving? I guess I'm not being clear with what, like, if I see the lab frame is unprimed, then I would say delta x is 3, and I wasn't being... Down there would be delta x prime, I guess. Delta x isn't measured like a train or anything like that. Like the traction about rigid bodies moving through space. D goes. I mean, just because it's not a rigid body, I thought distances between two events would, because that's about spatial distance. So I didn't think it mattered if it was a rigid body or not. Okay, I'm even more confused with the problem than ever. Um, spent 3 hours on a Sudoku. And Pravika, I think I can do that. I'll look in a second. I'm too stupid to understand what these rules are. What does it look like? This looks really annoying. I'm already struggling to understand the wording of special relativity. I can't understand the wording of the Sudoku rules. What's Pravika asking? I think there's some duplicated information here. Okay, I can do this. No worries. Okay, this is a physics problem I actually can handle. Physically, the situation we're looking at, here's the ground. Here's a platform that's 80 meters high. And then, pretend you have a cannon or whatever you want. It shoots out a projectile. That angle to the horizontal is 30 degrees. And if you want the time of flight, we're interested in when the y value, when the height of this thing is 0. And so if you know the equation for a projectile, for the height of a projectile, the y coordinate at any time is equal to the starting y plus the initial velocity times sine of the angle times time minus 1/2 times gravity, which is 9.8 t squared. You cannot draw a cannon like that. This is the perfect cannon. What do you mean? Oh. I guess you got your fake gay billionaire husband on your mind, don't you? Fine. Everything I'm gonna draw looks like a dick now. Okay, fine. No more dick drawing. We're just gonna have a ball there, and you can imagine how it's being thrown. Ugh. Even now the strong is even accurate. It's not perfectly from 80 meters, is it? There. Don does cannon drawings. Yeah. Usually I'm pretty good at spotting drawings that are secretly dicks. That one completely flew by me. And I tried to draw a cannon, which involved a wheel, and then a cannon piece, but of course that just looks like a dick that's going to the side. So if I plug in some more of the numbers here, the initial y is 80. The initial velocity is 40. One half times 9.8 t squared. Let's simplify a bit more. 80 plus. Actually, so this is the general equation. We're interested in when the y is 0, because that's what that point right there is. So I'm going to make y 0, and the goal is going to be to solve for t. Add some background decoration like a sun in the sky, makes the problem easier. And so from here, if you're allowed to do something like Wolfram Alpha, you could just plug that thing right in, or you could solve with a graphing calculator too. Otherwise, you're going to want to use the quadratic equation. Sine of 30 degrees is a half. So that's going to be 20t minus 4.9 t squared. And so you could, so I'm not going to solve this. Like, I'm just going to plug this into a calculator, because I don't want to write out the entire quadratic formula for that. 0 equals 80 plus 40t minus 4.9 t squared. Did I actually memorize that? Oh, it's 20t. It's 20t. We throw out the negative solution and we get 6.57. And this would be in seconds. It's a terrible S. Symmetry, it takes 40 over g seconds for the ball to complete the first arc going above the start elevation back down to the same height. I think that's a thing that you can do, Amadouam, yeah, but the starting height doesn't help us get to the ground, I don't think. I mean, I guess you could solve that as a separate problem, though. You can solve without Nico? If you're a genius, maybe. Yeah, what's up, Lucas? So yeah, Pravika, let me know if you have any questions about that. No worries. Oh god, Lucas, you're throwing a quotient rule at me. We can do it. Eureka echoes. Is that question cut off? Two minus x over root 4x minus x squared. You want to find the derivative of that? One-dimensional ball dropping? Yeah. Speaking of balls dropping, hey yo. See ya, Perbika. One question. Oh god, I don't know how to do that one question. I'm sorry. So yeah, so there's two approaches here, Lucas. Jasu is saying to write it like 2 minus x, 4x minus x squared square root to the -1. Or you could say it's to negative 1/2 power as well. You can do a product rule on that. Or with the original thing, you can do a quotient rule. I'm going to do the quotient rule. So that's usually what they expect you to do. But this way with the product rule is also valid. And so the way that I remember the quotient rule, because it's really annoying, is balls dropping. Nice. There's also exclamation point clip if you ever want to do it like a little bit easier. The way I remember the quotient rule is it's low D high minus high D low. And then you just remember the over low squared. And that's like referring to like the fraction high over low. At high. So whatever's on top is the high, whatever's on the bottom is the low. And low D high minus high D low just kind of rolls off the tongue nicely. Oh, I'm not factoring that in my head. Yeah, you have to let G equals 10. But yeah, so if I use that way to remember it, low, so low is the bottom part of the fraction, and that's just not, like, no derivative there, times the derivative of the high, which is just -1, minus, now the high, as it's written, times the derivative of the low, which is really annoying. Yeah, Emma. I'm going to do the derivative of 4x minus x squared square root separately, just because it's a little bit tricky. This is a chain rule. We start by taking the derivative of the square root piece. So if you have the derivative, say like, you know what? No, you know what? Okay, no. If we're taking the derivative of square root of x, it's like x to the 1/2, which is how you originally wrote the exponent. And so for this problem, it's probably better to keep it as the 1/2, but prime. Subtract 1 from the exponent, x to the -1/2, and then you... Sorry, bring the exponent down 1/2 times x to the -1/2. And x to the -1/2 is 1 over root x. So I tend to remember this derivative as 1 over 2 root x. So coming back up to this derivative, it's going to be the exact same thing for the square root piece. Just instead of that x, we have whatever is inside. So 1 over 2 root 4x minus x squared. But now we need to remember the chain rule and multiply the derivative of the inside, which is 4 minus 2x. And so we can clean this up. 4 minus 2x over 2 root 4x minus x squared. And then we can cancel a 2. 2 minus x over root 4x minus x squared. Okay. So the entire point of this is, for the d low part, I need to find the derivative of that, and now we've found it. So let's just go back to the formula and plug it in. And sorry, that was a very long-winded explanation of that piece of the problem. And then it's all divided by low squared, so we just get rid of the square root. Okay, and so technically this is the answer here, but they like to torture you and make you simplify this. So let's try to simplify it a bit. 4x minus x squared. We have 2 minus x times 2 minus x. So 2 minus x squared on top. X squared. Now on top, let's get a common denominator. This one on the left gets multiplied by root 4x minus x squared over root 4x minus x squared. Wolfram, it probably got the same thing. It just simplified it even more. Wolfram Alpha sometimes give you things that look different but are actually the same. Oh yeah, I am. So on top in this fraction, we get just 4x minus x squared. Subtract the other numerator, divided by the common denominator. All over that. We're nearly there. I need more room. Yeah, and so now my answer is probably going to match Wolfram Alpha soon here. And so now this denominator can multiply that denominator, and the exponents will add because it's the same base. So it becomes 4x minus x squared. Oh, that terrible 2. To the 3 over 2. There's still one more thing we can do, which is multiply out the numerator and combine like terms. So 4 minus 4x plus x squared. This part here is why the product rule or the quotient rule is really such a pain. All these simplifications. It's all just annoying to memorize. I mean, every part of the quotient rule is annoying. Let's be real. Okay, we have minus x squared minus x squared. So that's minus 2x squared. We have 4x minus negative 4x is 8x. And minus 4. I would probably stop here. You can mess with this thing even more. I don't think you get anything that's particularly simpler. The last step is just negative 4. You'd have to split it into its own fraction. Yeah, there's nearly a cancellation here, is maybe what you're talking about. But the 4 would still have the denominator there. So it's not quite so clean. Wolfram had a minus 4? Oh. It's possible I messed up a coefficient somewhere. I've been known to do that. The general technique here is the same, but I may have made a small mistake somewhere in here. Okay. What does Wolfram get? Just because I want to see. What the hell? That's not good. I mess up a sign somewhere? Why do they have a square root? Oh no, it's not. Okay, never mind. I meant like this sign is bad or these signs are bad. Something was supposed to cancel here and it didn't. Oh, I forgot this negative here. Well, there's your problem. So that becomes minus, that becomes plus. That becomes minus, that becomes plus. Minus, plus. Then these cancel and not add. Yep. Classic quotient rule. Error. Jasu. I saw it, but I know you love your product rule. But you still have to simplify that. At least most calculus classes would make you simplify that. Screw algebra? Hell yeah. Every kind of algebra. Homies and fellow girlies hate algebra. We're just doing a number theory PhD. Oh my god, that sounds like a nightmare. I'm looking at the answer to number 13. I'm so annoyed at 13. What? I did it right the first time. I Special relativity is the most confusing shit, dude. It's cool, but it's so confusing. Why is it longer? This is 0. This is 3. That's 10 to the negative 8. Oh, wait. So the second... Wait, what the hell? Why is it longer? That's what she said. Do an exercise where I need to completely dissect a function. Like the game. What? That sounds really annoying. Oh my gosh. If you're gonna clip every time I make a sex joke here, there's gonna be a lot of clips. Oh wait, are you clipping the what the frick, dude? Dude, frick is a fun word. Oh my gosh. Jose, I want to say. I was confused with your name. I think I was calling you Joshy before, and then I realized it was Jose, I think, if I'm remembering that right. Either way, thank you so much for the Prime sub. I really appreciate that. I hope you're doing well. Oh, that's true. I wish it could let you set the title, but it doesn't. Find both the single and double derivative function, look at both zero values, make a sign table from all three of the functions. Ugh. I have to do things like that, and it is really annoying. Especially if you're doing it with functions like the one we just did. Like, this thing would be super annoying to analyze like that. Yeah, I definitely verify the work you're doing with Wolfram Alpha. It sounds like you're already doing that, but I would keep on doing that. Okay, yeah, so it sounds like Lucas has to do with like this exact function here, and that's terrible. Eureka, okay, that's another piece of the question. So if you get it correct, oh my god. Yeah, these questions just kind of make you suffer. They're so annoying. They give you these because they have a lot of different sections to analyze, but they're very painful to do by hand. Um, they might want you to find the zeros of the original. It kind of depends on the instructions. A lot of times they'll just ask you to find the zeros of the first derivative and then use the second derivative to classify those zeros. They might want you to also find the zeros of the second derivative because they're inflection points, but Of the original function, they often don't care, but they might make you do that just because they hate life. See, Eureka, I can try to figure out your question, but I feel like I'm still missing a piece of it. But I do want to wrap up the stream soon, so if I don't hear the rest of the question soon, I'm just gonna sign off. It does, Amma the blame, yeah. The second derivative test, I mean, is not perfect. Um, Usually calculus classes don't throw those examples at you though. I think there's a fixed version of the test where you look at the third derivative, or yeah, the third derivative also. Um, we could grab a couple of mechanics questions while we wait. Yeah, what's up, Jose? Krish, those questions are normally really tricky, and I don't think that's the complete question, it looks like. But I'm normally not very good at those types of questions. All right, see you, Lucas. Sleep well. F prime 0. Yeah, the second derivative test, if it's greater than 0, if the second derivative is greater than 0, it's a maximum. If it's less than 0, it's a minimum. Do I have that right? No, I have that backwards. F double prime less than 0 is maximum because it's concave down. Yeah, Femvox, that sounds crazy. Oh no. This sounds like a puzzle. The setup to a puzzle question. Oops. Uh, Emma, I think I might wrap things up after Jose's question here. If it's a short one, like we can try and do it for fun, but my voice is kind of fading here. It's pretty short. I can take a look at it then at least, but I'm gonna be forced to cut the stream off pretty soon, just for the sake of my voice. Oh my god, that trig identity? Huh. That's kind of a crazy one. Uh, we can think about it for a bit after this one. After that, I think no more questions for the day, though. Like these would be like my last two. What happens if it's odd? If the sum is odd, what does the third button do? Like if I instantly hit the third button, one would be one, the other one would be two. This feels like you can set up some type of system of equations or something. I don't really know what it would look like though. Or even just a single equation, I don't know. You can't use it? Okay. Oh, I see. So I'm gonna add on that stipulation. I'm gonna phrase it like that because that's a little bit more clear to me personally, at least. Using Euler stuff? Okay. Um, button 3 sets x equal to x plus y over 2. It sets them both to be the average. That's what button 3 does. It only works for even sums. X plus y has to be even and positive. We can only use it if the conditions are met, or only if both x and y are positive and the sum is even. Otherwise, it doesn't work. Well, the button is made so that it doesn't work. You could still calculate that value, but an odd sum will be, you can't split that up. It's a constraint of the question that the button doesn't work. Okay, can I make x? I assume powers of 2 are important here. Can I double x until x equals 2 to the 256? Hey, Papadoria. I'm losing my voice. I'm not gonna be able to work on it today. If you want, you can put it there, and I can like type back to you at some point or look at it on Thursday. But I need to wrap the stream up soon. I'm sorry. Hey, Famished. Is chess math? Oh, I already said study. People actually use chess to study math. In a way, it can be. Yeah, it's infinite chess, which is chess on an infinite board, can be used to study infinite ordinals. And there's a dude who streams occasionally on Twitch called Admiral Stapler who did work on that. Wait, he's doing Minecraft now? What the hell? Um, can I find the? I actually watched a pretty interesting video on it. I don't know if I can find it again though. He hasn't streamed in a minute. Like he kind of goes through streaks of streaming a lot and then not much. Um. Ooh, is this the video? Yeah, this video right here. I watched it a while ago. It's a pretty interesting watch. Sounds good, Papadoria. Sorry about that. Fisher random, yeah. That's the next big wave in chess. The pros like it because you don't have to memorize opening theory that's like 20 moves deep. I think people are going to. I think there's going to be. I don't think it solves the problem of having to memorize a bunch of stuff, though. I think it makes it worse, personally. Slim coming out of the woodworks for an interesting problem. Wait, so sum 258. Slim is saying hit button 3. Why am I getting stupid? The 8 divided by 2. I can't do math right now. 1, 2, 9. That's what Slim is saying. What is this doing? Oh. Oh. The only thing you need to do is to get to a multiple of 5. Like we just need to get any number here that's 208 plus 5x. And this 258 is 208 plus 50. And so you can just keep subtracting off 5s until you get... Continue to subtract off 5s. And then... Or like we would just subtract off... Oh my god, I can't talk. Why do we need to keep on averaging? Why can't we just subtract off a bunch of 5s? You don't... Oh, okay. Sorry. Yeah. I figured it out now. Thank you. So the only reason we averaged the ones just to make it, just to give us enough like buffer on the y's to not go negative. But yeah, thank you, Slim. It took me a long time to figure that out. Okay, this is the last question of the day from Amidablam. Also, I hope that makes sense. Let us know if not. Thank you again, Slim, for saving me there. Yeah, I thought it'd be a lot harder. Sounds good, Emma. So I guess we're taking s equals sine of z. And so p of z is going to become negative sine 7z minus 1. Hopefully that's okay. Distinct real solutions. There should only be 7 total. And so I assume we're gonna restrict ourselves to like probably 0 to 2 pi for z. That might not be the right choice of the interval, I'm not sure. Oh, wait, the question is how many distinct real solutions are there? So I think we care to count how many of these are in quadrant 1 and quadrant 3. There probably is a complex number thing here. Not that I would know it. Um, but yeah, I assume we count how many of these are between 0 and pi over 2 and between pi and 3 pi over 2. And that's how we make sure they're distinct, because sine is the same value in quadrant 1 and 2, and then also in quadrant 3 and 4. Yeah. Um, 4 over 14. So 3 pi over 14, and then 7 pi over 14. I wonder if it's good to include those intervals or not. If k equals 3, get 15 pi over 14, 19 pi over 14. That's 21 pi over 14. Okay. So I think my answer is there's 4 distinct real solutions. No, I take that back. That it has to be an odd. There must be an odd number of real solutions. Because complex solutions come in pairs. What did I mess up? Yeah, I must not be considering the symmetry correctly, I guess. Where are all of these angles? Three pi over 14. Wait, 7 pi over 14. Just, that doesn't solve that. What did I do wrong? Wait, does it? No, yeah, it does. 11 pi over 14. 15 pi over 14. 19 pi over 14. One, two, three, four, five, six. 25 pi over 14. Wait, that's not 21 pi. That's what I was getting confused. Oh, good luck, Prem. Okay. Um, that one right on the border is the issue, because either we would take that set of solutions or that set of solutions. But 7 pi over 14 just seems like it works. Why would it not work? I'm gonna guess we throw it out for some reason, and the answer is 3. I don't really know, though. I can't get an extra one from somewhere. Unless, is there a reason? Okay. Uh, I think the answer is 3. I can't quite make this last connection, though. Uh, I'm basically out of voice, though. So I want to wrap it up. I don't mind a spoiler for this. Yeah, Emma. Uh, hey Joe. Drive-by primers, hell yeah. Yeah, I want to wrap it up, Emma. I My voice is nearly gone, so I think the answer is three. I can't quite work out why. The Mensa sign of Z. Well, the thing is, uh, the issue I'm having is that I think I'm doing that, but I'm getting four. There can't be four real solutions because I mean there's three complex solutions, and that can't be right. Thank you so much, Joe. It's going pretty good. It's been a full day. Hope your job is going well, dude. Yeah, Fembox. So that's my conflict here. I'm getting four, but four can't be right. So I think it's three, and I don't know how you resolve that. Uh, what should I be circling? Am I supposed to be circling these? Hey, color cone. Either way, the problem point is 7 pi over 14 in my mind, I think. But either way, I need to go. I'd rather just have the answer at this point. Only four distinct lines. But it can't be four. It's a degree 7 polynomial. That means there's three complex solutions, and that can't be right. Same old grind, different days. Rocket League tourney. Oh, good luck, dude. Thanks so much for the prime. Good luck with your tourney. Okay, yeah, I'm gonna dismiss it because I don't think I don't think it's possible for the answer to be four. It's what I'm getting, but I don't think it can be. I don't know what I'm missing if it is four. How's it four? I'll repeat it. God damn it. Okay, well, I solved it a long time ago. I thought that means they had to be complex. I forgot about repeated roots. Okay. I'm calling it there, guys. Thank you for the problem. Emma to blame. My voice is dying. I need to go. Yeah, anyone here on YouTube, thanks for being here. We're gonna look for a raid.